seen the basic things. Today we will see another perspective and we'll analyze the vertical circular motion in a better way, or our understanding will be solid. So you see, today's class we are going to do majorly on the basis of uh, uh, conservation of energy and application of work energy theorem, and with the equation also, force equation also, right? So let us start. Shrutik.
Sir, I joined just now only, sir. Anything
I
over,
know
sir?
nothing, just
Okay,
tell
sir.
me.
Okay.
Okay, so see, if I take a vertical track like this, and this is the level ground, we're also assuming that from here a block of mass m is projected with speed u, and 2 points I'm taking as I have taken yesterday also. This is point B, and here we are taking a point that is point C, right? If the block has to reach point B, yes Vignesh?
Sir, in cumulative test means
समझा नहीं.
cumulative test.
Is it the related to vertical circular motion?
No, sir. I am talking about test. There is after holidays there is cumulative test. What
So now about what I am talking? I am talking about test or I am talking about a topic?
topic, sir?
So concentrate here only.
Okay, sir.
So the block has to reach point B, and if I do energy conservation, so from energy conservation I can write kinetic energy at point A, this is point A, plus potential energy at point A is equal to kinetic energy at point B, potential energy at point B. So in that case, kinetic energy at point A I will write half mu square plus 0, because I am taking this as reference level, right, is equal to 0 plus mgr. So we will get u equal to root under of 2gr. That seems to be very fine. There is no problem with this. But now you see, if you draw the similarity, so now I am writing similarly. Similarly, if I try to write between A and C, now you see what kind of big problem we will face. Ka plus ua is equal to kc plus uc. So k of A is equal to how much? It is equal to half mu square plus 0 is equal to 0 plus mg into 2r, because this is r, this is r, total will become 2r. So what you are getting, that is u is equal to root under of 4gr. Wow. If you remember yesterday's result, then you know that this result is wrong. Wrong to okay, but why? Where we are getting it wrong? What is the thing that is making this result wrong? That we have to study in the subsequent process. Okay, is this fine for everyone? Did you understand the ambiguity? Tell me.
सर आपका आवाज बीच में लैग कर रहा है, स्लैग कर रहा है, आवाज ज्यादा कम हो रहा है सर.
तो जिस टाइम में ज्यादा हो रहा है उस टाइम पे कम सुनो, जिस टाइम पे कम हो रहा है उस टाइम पे ज्यादा सुनो.
सर जल्दी जल्दी हो रहा है सर, अभी भी आपका आवाज अच्छे से नहीं आ रहा.
मैं क्या कर सकता हूँ, मैं मैं तो रोज इसी माइक्रोफोन से चिल्लाता रहता हूँ। वरुण,
Sir, how kinetic energy at point C becomes zero?
minimum velocity required, that means it has adequate energy just to reach point C.
Okay, sir. Means it is not completing the complete rotation, huh, sir?
No. I'm just assuming that if it has to give sufficient velocity so that it just reach point B or it just reach point C.
Okay, sir.
Okay. Fine. So now let us proceed. Yeah. So let me add a page. Now let us see this entire thing in a different perspective. Now you see here, I'm again taking this curve, this track, sorry. So try to understand and be totally aware and concentrated in today's lecture, because this is conceptual as well as a bit confusing too. So please concentrate on the lecture. This is R. At any random time, I'm imagining that the block is here. Okay. I'm also imagining that this is the angle theta. So you people know that in this direction mg will act. So in this direction, component of theta mg cos theta will act, right? And this is the direction in which normal reaction will act. So from force equation, what can I write here? I can write n minus mg cos theta is equal to mv square by r. So n is equal to mg cos theta plus mv square by r, right? Shashi?
Sir, how normal reaction will act, sir? That it is a vertical circular is a track, no, sir? Then how normal reaction it is tension, no, sir?
Tension. It is not connected, it's a block ray. I'm not taking the example of the pendulum.
Okay, sir.
So now there will be a query that will come. Ki, sir, you have drawn the diagram for theta less than pi by 2. Is the equation valid for theta greater than pi by 2? Yes, it will be valid. So I will write this equation will be valid even for theta greater than pi by 2. So in that case, what will happen? That in this case, cos theta will be negative. And what is the significance of cos theta being the negative? Significance is that the component of mg along radius will be in the same direction, as that of normal reaction. That's it. Okay, this is the only change that will happen. And one more important thing is that very important note I have to take over here. You also remember it as a note, special note. What is a special note? For 0 less than theta less than pi by 2, in this interval, n will never become 0. Normal reaction cannot become 0 in this interval. All right. Why? Because in this interval, both mg cos theta and mv square by r are positive quantity. I hope you people have understood. Read every single step carefully, then respond. We will go ahead after this. Yes, Neita, tell me.
So once will you show previous page?
Yeah, sure.
Thank you, sir. So this is the first page?
Yeah, in today's lecture.
Yeah, okay, sir. Thank you.
Yogananda?
Sir, for n not equals to 0, why should mg cos theta square by r should be positive?
I'm not getting. You tell me.
Sir, for n not...
See, if n has to be 0, out of the two quantities mg cos theta and mv square by r, one has to be negative, one has to be positive. Now, then only one will cancel the other. It's a very simple thing here. Plus 2 and plus 2, can they ever become 0? No, na. 0 is only possible when it is plus 2 and minus 2. All right. Okay. So let's proceed from here. Now, what I will do, I will take this picture. Fine. So now here we took this as mg. So this is mg cos theta. So one more thing you notice, this entire thing is r. If I drop a perpendicular here, then this length, this much is coming to be r cos theta. It's a very simple trigonometry. So this height from the ground, it is coming to be r into 1 minus cos theta. So now if we apply work energy theorem, then work done by gravity is equal to change in kinetic energy. All right. So if you check, the body is moving up, so work done by gravity is negative. So minus mg into r into 1 minus cos theta is equal to half mv square minus half mu square. So let us simplify the result. We will get v square is equal to u square minus 2gr into 1 minus cos theta. It means we'll get v square is equal to u square minus 2gr plus 2gr cos theta. Is it fine for everyone? So this is the equation we got correlating the velocity at that point, initial velocity and angle theta. Okay, na? Let us call this as equation number 1. Is this fine for everyone? Please respond. Okay, fine. Shall we move ahead now? Right. So now we are going to frame the equation for n, that is for normal reaction. Um, yeah, Harshit.
Sir, in this diagram, the total length, the total radius is also r. Then the small part you take, even that is r, sir.
No, 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 no. How that is? This is not r. This r is the total r. This is itself. They're same.
Okay, sir.
Is it okay now?
Yes, sir.
Yeah, right. All right. Fine. So let us move on. Now we will go for normal reaction. So for normal reaction, I have already written the equation that n is equal to, have written mg cos theta plus mv square by r. So let us substitute the value of v square plus m by r. V square means u square minus 2gr plus 2gr cos theta. Then capital N will become mg cos theta plus mu square by r minus mg plus 2mg cos theta. Okay, fine. On further simplification, n is equal to, we are getting mu square by r minus mg plus 3mg cos theta. Did I do correct? No, I think here 2mg will come. No, yes, that is 2mg. Okay, so this is the normal reaction that we are getting. Right, this is equation number 2, let us say. Okay, now we will do case study one by one. Slowly we'll see all the cases. Okay, so first case 1. In case 1, closely see which equation I am using when. Case 1, I am taking, that is theta is equal to 90 degree, that is at pi by 2. So at theta equal to 90 degree, we know, I mean, simply we can write 0 is equal to, using equation 1, 0 is equal to u square minus 2gr plus 2gr cos theta means that is also 0. So u is equal to, root under of 2gr. Acha, come to a point one by one. What is u here? U is the minimum velocity required to reach B. Next question is, sir, why did you use equation number 1 instead of equation number 2? See, I already told you previously that for any value of theta which is less equal to pi by 2, normal reaction is not going to be 0. Correct? So if normal reaction is not going to be 0, then I cannot use this equation. But yes, if it reaches exactly point B, then what will be the situation in this case? What I'm supposed to write? In this case, the motion of the particle will be like this. Check out carefully. So this is base point A. Here is the point B. All right. This is point B. So particle on the body, the block is projected from here. It goes to point B, comes back, crosses this point, exactly goes to the other point. If this is a D, let us say, and then comes back. So it basically moves around. So the motion of the block is how? A, then to B, then to A, then to D, then to A, continuing. Correct only for understanding, right? Now next point I'm writing, exactly at B, exactly at B, N will become 0, but it won't lose contact with the track, right? For an instant, normal action will become 0. Immediately it will come when it is returning back. So you see, when the block is here, for an instant, normal action will become 0. But since it is coming back again, so immediately it is in contact with the surface. I hope this is okay now. Everyone respond if it is okay. All right, thank you. All right. So now let us move on to case 2. हाँ क्या विल हुआ?
सर पिछला पेज दिखाओ
अब लास्ट में बताना.
सर एक ही स्क्रीनशॉट लेना है सर.
बहुत डिस्टरबेंस होता है यार, ये आगे पीछे करके ना बहुत डिस्टरबेंस होता है.
सॉरी सर.
मैं लास्ट में दिखाऊंगा, 5 सेकंड का टाइम दे करके उस टाइम पे स्क्रीनशॉट उतार लेना.
ठीक है सर.
So now in case 2, what I'm going to do in case 2? Case 2, I'm going to take u less than root under 2gr. It means the velocity is now not sufficient enough to reach point B. So it means what? Before reaching B only it will come to rest. है ना? So in this case what will happen? बिगनेस को देख एक बार, साले भालू जैसे यॉर्निंग कर रहा है. So in this case, the block will come to rest. Vignesh, good morning. Before reaching breakfast and brush done, na?
Completed sir.
Completed. When? 2 minutes back.
No sir. At 9:30.
At 9:30. अभी 2 दिन पहले क्या बोला था सर? मैं 5 बजे उठ जाता हूँ.
हाँ.
तो 9:30 में ब्रश कैसे हो गए फिर?
प्रश्न है सर.
बेटा फंस गए आज. चलो. So the block will come to rest before reaching point B. Right? So if the block comes to rest before reaching point B, I say just let us take a random example. For example, let us take u is equal to root under of gr. Just random example I am taking. Any velocity which is less than root under 2gr. So for this velocity, what will be the equation that we'll be using? Since velocity is becoming 0, so I will write from equation 1. From equation 1, from equation 1, 0 is equal to u square. U square means gr minus 2gr plus 2gr cos theta. If you solve this equation, cos theta you are getting it to be half. So theta is what? 60 degree. So that means at an angle of 60 degree, the block will come to rest if it is given a velocity which is lesser than root under of 2gr. Correct? Now here also I can make one comment. What is the comment I can make here? I will write here that in this case also I will write that at 60 degree, the body will stop momentarily, means instantaneously. Why? Because the tangential acceleration will not allow the body to be at permanent rest. Like if you look at the diagram, the diagram will be like this. So let us assume that the body is here. This angle is 60 degree. This is the direction of G, and tangentially in this direction, G sin theta will act. Correct? Fine, no? G sin 60 degree actually. So this will pull the body. This will not allow the body to be at permanent rest. Clear? Fine. The situation is clear to everyone. Okay. So now the situation we are going is the second case, then third case. What is the third case? Third case I am writing, what if theta greater than pi by 2? Till now, whichever case I have discussed, either theta is equal to pi by 2 or it is less than pi by 2. So what will happen if theta is greater than pi by 2? Very interesting thing will happen. What will happen? In this situation, we will write that here the normal reaction will become 0 before velocity. Here in this case, before velocity comes to 0, normal reaction will become 0. Correct? And the answer we got there, root under 4gr, was wrong because of what? Because we made velocity 0, not normal reaction 0. Correct? I hope you got the ambiguity. It is clear now. So whenever you are crossing 90-degree limit, to get the minimum velocity to reach that point, you should never make velocity 0. You have to make normal reaction 0. So in this territory, we have to use equation 2. Right? This is not the zone to use the velocity equation. This is the zone in which you have to use equation number 2. Okay? Fine. Is that fine? Correct? Fine. Abhi see how it is acting actually. Now, in the next page I will show. Now the minimum, yes, tell me. Minimum velocity, हाँ tell me.
जब थीटा 90 डिग्री से बड़ा होता है,
हाँ,
तब ब्लॉक में क्या होता है?
हाँ
What
क्या
happen
क्या?
in block? जब थीटा 90 डिग्री से बड़ा होता है,
हाँ,
तब what happen in block?
what?
What happens with block, sir?
What happens with block? ये अब तक तो यही बोल रहा था, ब्लॉक के साथ ही क्या हो रहा है, तो वही तो बोल रहा था. हम लोग के साथ टॉर्चर तो हो ही रहा है क्योंकि हम लोग फिजिक्स पढ़ रहे हैं, वो छोड़ दे. ब्लॉक के साथ यही होने वाला कि ब्लॉक का नॉर्मल रिएक्शन 0 हो जाएगा, वेलोसिटी 0 नहीं होगा.
हाँ सर, ओके सर.
Okay. So now we will be using equation 2. Now from equation 2, भाई याद कर लो equation 2. What was equation 2? N was equal to mu square by r minus 2 mg plus 3 mg cos theta. यही था ना भाई? Right? That was the thing only, no? So now what I have to do, Ray? I have to make normal reaction 0. And to reach C, theta का value क्या होना चाहिए? What is the theta value? 180 degree. This is -1, then cos theta is -1. So what is the equation turning up to be? 0 is equal to u square minus r से मल्टीप्लाई कर दो 2gr minus 3gr. बल्ले बल्ले, we got our result, no? This is exactly what we have predicted in yesterday's class. Right? This is the result we have predicted in yesterday's class. तो कल क्लास में जो लोग सोए हुए थे उन लोगों के लिए मैं दिखा देता हूं एक बार. हाँ साहब जी, देख लीजिए, यहाँ पे लिखा हुआ है u is equal to root under of 5gr. Vignesh, u equal to root under 5gr. No, I am not saying that you were sleeping yesterday. अभी है ही नहीं, भाग गया किधर देखो. ओके. कितना बुद्धू आदमी है, देख कैमरा ऑन करके भाग गया. हाँ बोल.
सर बेचारे को हिंदी समझ में नहीं आता तो कुछ भी बोल दिया.
ओके चलो, लेट्स प्रोसीड.
सर उधर बैठा है देखो पीछे.
नहीं 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 है क्या? नहीं है, नहीं है.
है सर.
मुझे कि कोई मुंडी ला रहा है वहां पे. भाई भाई होगा. चलो ओके फाइन. सो नेक्स्ट अब now in this situation, after getting u, see now if we go back to equation 1, कितना इंटरेस्टिंग है देख. v square is equal to u square minus 2gr plus 2gr cos theta was the equation, right? So u square means how much you got? 5gr minus 2gr. Cos theta is -1 here also, so minus 2gr. How much you got? Gr, no? So velocity at point C, how much you are getting? Root under gr. फिर चेक कर. C, root under gl. Correct? Okay, very good. Right. So after we get that, what I have to keep in our mind is that in these two values, I mean for these two values, when u is equal to root under 5gr and v is equal to root under root under gr only, so we will take a note here. What is the note? The note is that in this situation, the body will just complete the vertical circular motion. Okay, so in this case the body will just complete the vertical circular motion. Okay, is it clear to everyone? Please respond. Yes, honorable professor, please.
सर हाफ ही तो रेवोल्यूशन होगा.
हाफ रेवोल्यूशन होगा?
यस सर.
फिर उधर से क्या होगा? पेड़ से एप्पल की तरह टपक जाएगा बे.
सर उसके बाद वो पीछे लास्ट नीचे वाले पॉइंट पे ही तो आ जाएगा फिर से.
साला इतना जल्दी क्यों भूलता है बे? अभी काली तो पढ़ाया भाई कि दिस इज द मिनिमम वेलोसिटी रिक्वायर्ड जस्ट टू कंप्लीट द वर्टिकल सर्कुलर मोशन. अगर इतना वेलोसिटी हम लोगों ने दिया, इफ वी हैव गिवन दिस मच मिनिमम वेलोसिटी एट द बॉटम मोस्ट पोजीशन, तो वो जस्ट टॉप पॉइंट को क्रॉस कर जाएगा, इट विल जस्ट क्रॉस द टॉप पॉइंट।
ओके सर।
तो कैंपस में आ, उसके बाद तेरे को मैं देखता हूँ, रुक अभी। हाँ बोल।
सर चॉकलेट बॉम्ब सर।
प्रोफेसर ना?
हाँ सर।
वो कैंपस में आने देना उसको एक बार।
सर अगर वो टॉप मोस्ट पॉइंट का वेलोसिटी √5 GR से थोड़ा भी कम होगा तो क्या होगा?
नहीं होगा ना, फॉल बैक कर जाएगा, वो मैं बताऊंगा अभी, अभी रुको, दैट आई एम गोइंग टू डिस्कस द नेक्स्ट पॉइंट, आई एम गोइंग टू डिस्कस दैट वन ओनली, जस्ट वेट। ओके चलो, सो नेक्स्ट आई एम कमिंग टू केस 4। सो केस 4 is if u is greater than √5 GR. So if u is greater than √5 GR, then what will happen? The body will freely move in the vertical circular motion and n will never be 0 in this case. So that's the only point you need to remember. So here in this situation, if u is greater than √5 GR, minimum velocity required is this much. If you give anything greater than that, aram se, it will seamlessly complete the vertical circular motion and will keep on revolving. Okay now? Now, most important case is coming from where you will actually get question in JEE Advance or Main is case 5. That case is √5 GR greater than √2 GR. Okay? So now I will make you understand. So please be careful with the diagram. Okay. So here we have point A. This is point B. This is point C. And this is point D. So see one thing, that u is equal to √2 GR is just sufficient to cross point B, and u is equal to √5 GR is sufficient just to reach point C. Okay ना? हाँ बोल।
सर 3 GR था ना, √3 GR था ना कल?
कौन सा?
सर पॉइंट बी को क्रॉस करने के लिए।
नहीं, रीच अभी वहां पे रीच करने के लिए।
हाँ
वो तो अगर नो 3 GR था, गलत सोच रहा है। If the velocity at the bottommost point is √5 GR, then B पे velocity √3 GR है. But to just reach point B, what the velocity required at point A is √2 GR. So don't get confused between these two. है ना? Okay. So I will write here that √2 GR is the velocity needed just to reach B, and √5 GR is the velocity needed just to reach point C. Correct? The velocity which is given is in between them, so it will stop somewhere between B and C. So I will write that in this case, the body will stop somewhere between B and C. Is that okay? ये concept clear है कि नहीं पहले बताओ. Everyone please respond if this concept is okay or not. Any doubt, emotion, frustration, anguish, anger, feel free to express. हाँ दिनेश. दिनेश చెప్పండి. Anybody has any doubt? Tell me.
Sir, where it will stop, sir? In between the B and C or exactly at the center, sir?
That I do not know where exactly, because the velocity is given. Is it given to you?
No, sir. No, sir. It is.
It's a range only, no?
Yes, sir.
So depending upon the value, it will stop somewhere at any point between B and C.
Okay, sir.
Okay. Sai?
Sir, could you please show the previous page?
Yes, sure. Okay.
Okay, sir. Thank you.
So now, let me take this diagram again. Hold on. All right. So this is point C. This is A. Okay. Now what I'm going to say, look at this very carefully. Suppose it comes to a point X. Suppose this is point X, right? So at this point X, try to understand. This is the direction of mg, right? So if I take this angle to be theta, then the component of mg in this direction is mg cos theta, right, Ray? And it is the same direction in which centripetal force will also act. So now at X, mg cos theta and F centripetal are in same direction, and these two will pull the body from the track. If they pull the body from the track, normal reaction will become 0. So what we have to remember, that in the velocity range, root under 5gr greater than u greater than root under 2gr, normal reaction will be 0 before velocity. Correct? So precisely telling, at point X, normal reaction is 0, but velocity is not equal to 0. Try to visualize and tell me if you have understood. भाई अगर यहाँ पे समझ नहीं आया ना, तो कहीं पे समझ में नहीं आएगा यार. Nobody can make this much easy. Varun?
Sir, theta is the angle from A to X or B to X?
In this case, I have taken only from B to X.
Oh, then.
But actually, the angle is this one.
Okay, sir.
You do one thing. I got your ambiguity actually. Better we will do one thing. We'll take it some different angle alpha. Is this fine now?
Okay, sir.
Yeah, right. So we will take here also alpha.
Sir.
Sir.
Sir, in the case 4, you told that. Sorry, sir. Just a little misunderstanding.
देखो रे, देखो. गोपाल आया. हाँ हर्षित, tell me. Likita?
Sir, explain that blue part again, once again.
See, this is the surface in contact, no?
Yes, sir.
This is the surface in contact, right?
Yes, sir.
In this surface, if both component of mg and centripetal force are acting in the same direction, what is there? Is there any force to press it against the surface?
No.
No. So obviously it will leave the contact with the surface.
Yeah, yes, sir.
So that's why I have written, since they are in same direction, so these two will pull the body from the track.
Okay, sir.
Joshika madam,
Okay.
Chepandi. Joshika, tell me.
Hello.
Yeah, madam, Chepandi.
Sir, root 5 GR is the velocity needed to reach C from A.
Yeah, root 5 GR is the minimum velocity that should be given at point A so that it can just reach point C.
To cross C, it is root GR. Is it?
No. Root GR is the velocity at the top point. Root 5 GR is the velocity here at point A. Root
Yes, sir.
GR is the velocity at point C.
Oh, okay.
Okay.
Okay, sir.
Harsha?
Sir, my internet connection was lost, sir. What have you told in the past 5 minutes, sir?
बहुत कुछ बोल दिया यार, जो बोला ये सामने है अभी.
Okay, sir.
इसको देखो एक बार. सुजल?
सर अगर वेलोसिटी रूट 2 रही तो बी पे 0 रहेगा नॉर्मल.
हाँ राइट.
और रूट 5 रही तो सी पे 0.
0 नहीं होगा, क्रॉस कर जाएगा वो.
नॉर्मल 0.
नॉर्मल 0. हाँ.
तो डी पे क्या सर?
कौन सा?
डी पे डी.
डी सेम सिचुएशन एज बी ओनली, नो?
अच्छा ठीक है.
ठीक है ना?
थैंक यू. हाँ सर.
ओके. दिनेश बाबा?
Sir, what is the angle between mg and mg cos alpha, sir?
What is the
angle between mg and mg cos alpha?
ये कोई बात है यार, क्लास 9th का क्वेश्चन है. This is 90 degree minus alpha. If this is alpha, this is 90 degree, so this is 90 degree minus alpha. ये sin alpha होगा actually, I think so. This component will become sin alpha.
Yes,
mg sin alpha. Anything else?
That only doubt, sir.
Oh, that only is the doubt. Yeah, thank you very much. Yeah, Divit?
Sir, that means in case 3 and case 5, only normal reaction will be 0 before velocity not equal.
Yes, sir.
Okay, sir.
Professor, you raised your hand, then you flied somewhere. What is the matter? Honorable Professor, you have any doubt? Yes, Professor.
सर mg sin थीटा के वजह से वो फिर से ट्रैक पे आ जाएगा ना?
कौन सा?
mg sin
इस केस में?
हाँ ये
बताता हूँ इस केस में क्या होगा. रुको, तो हमारा नेक्स्ट डिस्कशन है.
Okay,
what
sir.
will happen. So just 2 minutes I will take again. So now in this case, what is going to be the subsequent motion? So here is the body, block of mass M, center O. We have given some velocity u. What is the range of u being provided? That is root under of 5gr greater than u greater than root under 2gr. So definitely it is going to cross point B. Here is point C. Can't reach point C, so it will come to rest at somewhere at point X. As we have seen, we have taken this angle as alpha. So here is the body now. So at this particular position, what we are writing, ki by n is equal to 0, but v is not equal to 0. So that means it will have some velocity in this tangential direction. Right? क्या हो गया? हाँ, okay. So it is now, since it is leaving contact with the ground, see what interesting phenomena will happen. So it will move in a projectile from here. So from here, it will move in a projectile. So I will write in this situation, if this is alpha, this angle is also going to be alpha. Okay. So in this situation, the body will leave contact with the track at point X and will then move in a projectile. I hope you have understood. Please respond. Everyone, please respond if it is okay for everyone. Right? Okay then. देखो. Yes sir.
सर वो वापस से ट्रैक पे क्यों नहीं आएगा एमजी साइन थीटा के वजह से?
एमजी साइन थीटा की वजह से? एमजी
साइन अल्फा.
साइन अल्फा तो इस तरफ काम कर रहा है, वो ट्रैक पे कैसे आएगा?
सर वो तो एमजी कॉस अल्फा काम करेगा ना.
ये एमजी साइन अल्फा है, एमजी कॉस अल्फा तो इधर काम कर रहा है, इस तरफ काम कर रहा है. ये एमजी कॉस अल्फा है.
हाँ तो एमजी कॉस अल्फा की वजह से क्यों नहीं आएगा?
अबे इस तरफ फोर्स ज्यादा है ना, एमजी साइन अल्फा प्लस एमबी स्क्वायर बाई आर है, इस तरफ फोर्स कम है, तो
ओके
जब
सर.
फोर्स जिस तरफ ज्यादा है उस तरफ ही भागेगा ना.
हाँ ओके सर.
ठीक है ना? ठीक है. ओके चल फिर, बाय बाय. Bye everyone. Bye bye. See you tomorrow. Dasera holidays is fastly approaching. Bigness Mama, preparation for holidays completed?
Sir?
Preparation for holidays completed?
Yes, sir.
How many new dresses?
No, sir. No new dresses.
Yende kure Mama.
Sir, college कब start होते हैं?
Yeah, this is Olympiad level question. Nobody can answer. Hardik, tell me.
सर कॉलेज कब स्टार्ट होगा सर?
यार तू फिर से वही पूछ रहा है भाई.
वही सर. ठीक है सर, दशहरा हॉलीडेज कब चालू होगा वो बोल दो.
दशहरा हॉलीडेज 23rd से है शायद.
23rd से?
वो पता नहीं.
ठीक.
गोवानंदा. Louder, louder.
Sir, can we say that the due to inertia of motion from the point X the motion will follow?
हाँ बोल सकते हैं. We can tell. दिवित.
Sir, this week vertical circular motion is there, na sir?
पता नहीं. We'll tell. This week means
Okay,
how exam will be conducted in this week? You tell me.
The 22nd in schedule it's showing 22nd and topic start from 9th dated to 21st, sir.
9th date to 20?
9th to 21st. Yes, sir. Yes,
No,
sir.
this
Only
even if the syllabus is there, na, the syllabus will be up to the equilibrium. Vertical circular motion is not there, I think.
Okay, sir. Okay.
ठीक है, चलो, okay, bye bye now, bye 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 everyone. Professor sir, bye.
I live inside my own world of make-believe. Kids screaming in the cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Take my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Someday